Today we're going to be reviewing our properties of exponents. So the first thing you want to do is open up the notes that you got from the sub, and very quickly we're going to just remind ourselves about our exponent properties. So remember, we use these properties when a and b are real numbers. So those are our bases, and we also want to have integer exponents of m and n. So here, when we're looking at this, these are the same bases. So we could add their exponents, so it's a to the m plus n. Here, it's the same bases, but we're dividing, so we subtract exponents, a to the m minus n. Remember, a negative exponent means I can express this as a fraction, 1 over a to the n. A to the 0 is 1. We also have this property with parentheses. So if I have ab parentheses to the m, that's the same as a to the m, b to the m. Similarly here, when I have an exponent raised to an exponent, I multiply my powers. This is the same as saying a to the m divided by b to the m. And then my last one here, if I have a to the negative n, that's really like 1 divided by 1 over a to the n, which if you think about change to multiplication, take the reciprocal, is 1 times a to the n, which is just a to the n. So those are your exponent properties that you talked about when you were in Algebra 1. So that was just a quick reminder. I'd like you guys to use that idea and try example A. So pause the video and give that a try. Okay, at this point, you've tried it, and you wanted to make sure that you follow the directions. They only want positive exponents. So if you keep in mind here, my numerator didn't have any parentheses to deal with, so I'm going to leave that as it is. My denominator, this is 4 to the third times r to the third. So here you have two options. You could think of this as 4 to the first, and you could subtract exponents. Or if you want, you could think of this as 4 over 64. And then my r to the fourth and my r to the third, when I subtract, it becomes r to the first. So this is going to reduce to r over 4 64ths reduces to 1/16. Again, I want you to pause and try question B and question C. Okay, at this point you've tried B and C. So anything with parentheses, I would simplify that first. So 2 to the fifth becomes 2 times 5. And then here, the 2 and the 5 are not like bases, so they have to stay as is. And then 10 minus 5 is 5. So you could either keep this in the numerator because it's a positive exponent, or an equivalent statement would be 2/5 p to the fifth. For my last one here, I'm going to deal with my exponent. So I have 20 t to the negative 6, a to the negative 3. This is 4 to the negative 2. When I multiply these together, I'm going to get 6. When I multiply these together, I get negative 4. So now my 20 over 4 to the negative second, I'm actually going to leave that for a second. And I'm going to deal just with my variables. So when I look at my exponents that go with t, I have negative 6 minus 6. That's negative 12. When I deal with the exponents for the a, I have negative 3 minus a negative 4. That's 1. So right now I have 20 over, this you could think of, if you want to deal with that too, 16 to the negative 1. And then right now this is t to the negative 12. and a to the first. So when my t is to the negative 12, that I could bring down to the denominator. And if I want to deal with 20 divided by 16 to the negative 1, that's really 20 times 16, because this is 20 divided by 1/16. That's going to give me 320. If you're feeling a little shaky with that, you could check on your calculator. Now, my a stays in the numerator. Because that t is to a negative 12, I'm going to move it down to the denominator. So this is going to be my final answer. Everything has a positive exponent. Okay, so now we're going to jump to something that uses these skills that you did a little bit in Algebra 1, but you might need a little more practice. So here, these all ask us to rewrite this in the form f of t equals ab to the t. So it needs to be an a times b to the t, and there can't be anything attached to my exponent. So what we're going to do is we're going to rewrite this kind of like unraveling our exponent. So I'm going to think of this as 3 to the t times 3 to the negative 1. Basically, I'm giving that exponent to the 3 inside the parentheses in 2 pieces. That's the same thing as rearranging it like this. Remember, multiplication, I can change my order. So now my b to the t part, that's satisfied by this. But they wanted the front part of it to look like an a. So I need to multiply these together. So this is going to be 2 times 3 to the negative 1. Well, 3 to the negative 1 is 1/3. So here, 2 times 1/3 is 2/3. So my final answer here is 2/3 times 3 to the t. So this is f of t equals 2/3 times 3 to the t. You're going to use the same idea, and you're going to try to rewrite example b for me. So I need to pause the video, try to rewrite example a. Okay, at this point, you've tried to rewrite example b. So we're going to use the same strategy where the t is going to go to the 4 and positive 1 goes to the 4. This one's a little bit easier because now you just do 4 to the first times negative 100. So it's negative 400 times 4 to the t. The last one's a little bit tricky. You could pause the video and try it. It's something that I'd want to go over with you guys in class if you got stuck. If you did try it, you should be achieving a final answer of 5 times 4 to the t. Okay, very last thing that I want to show you guys is Algebra 2's version of a proof. It's much easier than what you have to do in geometry. So basically, you know you're doing a proof when they give you an equation and they ask you to verify, and they usually use the word identity. So what we're going to do is we need to show that one side of the equation is the same as the other, and we do that using our exponent properties. Now, we don't have to do like statement reason proof. We just have to show our thought process. So usually I pick the side that has a little bit more going on as the side that I use as my given, so to speak. So I'm trying to make this side look like the other side of the equation. I'm showing that they're actually equal to each other. So what I would do is I'm going to actually break this down. So the first thing I would do is say 2 to the n plus 1, well, that's the same as 2 to the n times 2 to the first. And that's over 3 to the n. Well, we can rewrite this as, I'm just going to like switch the order around. And this is multiplication, so we're allowed to do this. So this is 2 to the first times 2 to the n. And then I'm just going to write this over 3 to the n, which is fine. And so the same thing. Now 3 to the n, the denominator, I could bring that up by rewriting it as 3 to the negative n. actually, let's not bother with the negative. Maybe you guys can see it this way. If it's 2 to the n and 3 to the n, technically, we could rewrite that as 2 over 3 to the n. Now that we've moved these around to look the same as the right-hand side, we're literally done with our proof. So we just use exponent properties to rearrange everything to make it match. Now, sometimes it gets a little tricky, like question C. They're not all the same base at the beginning of the question. So if you're trying to do a question like question C, you want to rewrite these so they look like they're in the same base. So if like this is the power of 2, we know by the end we're probably going to have to have everything as a power of 2. So you need to ask yourself, well, what power of 2 is 64? So take a minute and think about what power of 2 do I need to get 64? And that's going to be 2 to the 6th. So I'm going to rewrite 64 as 2 to the 6th. I can also rewrite 4 as 2 squared. So I'm literally going to replace everything on the left-hand side of the equation with that. Now, if you wanted to work with the right-hand side first, you could have, and then you need to make that look like the left. I think it's easier working with ones that have a little more to work with, but it's whatever makes you happy. So now, I have this, and I'm going to write this as 2. This is a power to a power. So this is 4n. After I do that, since these are the same base of being multiplied, this is 2 to the 6 plus 4n, which is the same thing as 2 to the 4n plus 6. So our proof is done. So these proofs are pretty fast. And really the hardest part for people is just deciding which side to start with. I would recommend with starting a side that has more going on and less. You don't want to cross the equal sign. You have to stay on one side. So I'd like you guys to, for the last part of the video, I just want you to try part B and pause the video and then unpause when you're ready to check. Okay, so at this point, you've tried this question already. So there's a couple options for part B. You could start with the right-hand side or the left-hand side to try to show that it's the same thing. So one thing you could do, if you have 2 times 3 to the n, is you know that's 3 to the n plus 3 to the n. And you could try to work through that, but that's kind of hard. It's kind of hard to start to make that look like the left-hand side. So I think if I was doing this, I'm going to try to work the left-hand side, and I'm going to start rewriting things. So 3 to the n plus 1 is the same as 3 to the n times 2 to the first. Then I look for things they might have in common. Now, remember, in Algebra 2, when you get stuck on something, factoring is key. So they have a common factor. You could factor out a 3 to the n. You'd be left with 3 to the first minus 1. And that's actually the key to this problem, because 3 to the first minus 1 is 2. And that's the fastest way to get this. This one was a little bit tricky. All right, at this point, you can work on your homework. If you finish your homework, you could try to finish up your delta math. I'll see you guys on Monday.